Good morning. So today's I'll be presenting a flash talk on screening and development of effective phage cocktail against Acinetobacter baumannii. As you all are aware, as you all are aware that Acinetobacter baumannii is clinically relevant as it causes up to 20% of the total ICU infections globally, and it causes mortality of about 8.4% to 36.5% of the people, depending upon the region. So the basic problem has started because of the MDR, XDR, and PDR strains of the bug. Antimicrobial therapy is not effective and longer duration of treatment is required, which causes more economic burden on the country and the people. And more recently, carbapenem resistance Acinetobacter baumannii has emerged globally, as you can see from the graph here, and it causes ventilator associated pneumonia, UTI, wound infection in hospitalized patient, which is very difficult to treat. So for the genotyping of the Acinetobacter baumannii, most commonly people use multilocus sequence typing, and in that Pasteur scheme is more commonly used. Which divides bacteria according to the 7 genes as listed here. And the ST1 and ST2 types are the most dominant strains which causes hospital acquired infection in the Asian countries. So coming to the knowledge gap, the XDR, MDR, and PDR strains of Acinetobacter causes the nosocomial infection, but there is no effective drug to treat them. But recently, phage therapy has emerged as a promising new therapy. But a problems associated with it is that the phages which are isolated are not selected against ST1 and ST2 types, which causes most of the nosocomial infection in the Asian countries. So our goal is to develop a collection of phage that identify all the ST1 and ST2 A baumannii strain with least probability of development of resistance. So for this, we isolated and produced 30 phages from sievages, and we went on to spot those phages to identify their on host range on the different clinical isolates which were gotten from the SGH hospital, which is Singapore General Hospital. And after spotting them, we got to know that our phages identified and killed most of the ST1 and ST2 which are present in the clinics. And nevertheless, it can target the other ST types of A. baumannii and some of the other species of Acinetobacter as well, apart from just targeting the ST1 and ST2 types. So from the previous graph, we try to quantify the number of strains killed by our phages so that we can narrow down our phages for further work. So we got to know that most of the phages infected our ST2s and ST1s except for some. So then we went on to analyze the result for the overall Acinetobacter, and we got to know that our phage 5 and phage 8 and 9 demonstrated the highest lytic activity. So then we performed a bacterial killing curve for our selected phages, both in singles in cocktail of 2 and in a cocktail of 3 phage in one go. But to our surprise, we got to know that there is no specific type of killing activity which was observed for our phages, either single or cocktail. Both the single phage and the cocktail work differently, even within the same ST types. So, which we concluded that, through this preliminary assay, we concluded that our phages selectively show the killing type. And for confirmation, we still need to do the CFU assay for the time period so that we can for sure quantify the effectiveness of our phage cocktail versus single phages. Thank you.